Good morning, scholars. Welcome to our new lesson for today. In today's lesson, we're going to be talking about how to use tape diagrams to model and solve fraction word problems. These fraction word problems are going to help you with the word problems that are on page 29 of your packet. The word problems we're going to do not look exactly like those word problems, but the concept and the skills are the same. So they're meant to help you practice those skills before you work on it independently. There are not a lot of word problems in today's lesson because each word problem has so many steps to it. So I want us to focus and spend some time on those individual steps. Number 1. Kim and Courtney share a 16-ounce box of cereal. By the end of the week, Kim has eaten 3/8 of the box and Courtney has eaten 1/4 of the box of cereal. What fraction of the box is left? Let's think about what we know, starting with the whole. Do I know my whole, and if so, what is it? If you said 16 ounces of cereal, you are correct. My whole is the 16 ounces here. Let's think about the fractions that we know that are coming from this 16 ounces box of cereal. I know that Kim ate 3/8 of the box, and I also know that Courtney ate 1/8 of the box. If I wanted to model 3/8 and 1/4 on the same tape diagram, that would be pretty hard, right? Because my denominators, the total number of units in that box would be different. Kim would have 8 units total, and Courtney would need 4 units total, so it doesn't really match up. That means that if I want to show these two fractions on the same tape diagram, I need to change these fractions into equivalent fractions, which means they have the same denominator. We've covered equivalent fractions in class before, and we also covered it in a lesson last week. So I'm going to change Kim and Courtney's fractions into eighths. 8 is the common denominator, or the common multiple, that both 8 and 4 share. If you had a hard time figuring out that 8 would be our common multiple, I'd like you to pause this video and list the multiples of 8 and 4, or you can pause the video and go back to last week's video, watch that, and come back here. Now 3/8 would become how many eighths? It would stay the same. 1/4 would become how many eighths? 2/8. Now I have enough information to be able to set up my tape diagram because now I can have equal units. So my tape diagram is going to be split into how many units? If you said 8, you're correct. My whole is the 16 ounces. And now I can label which of these units Kim ate and which of these units Courtney ate. Now Kim and Courtney have 3/8 and 2/8. So Kim has 3 of those 8 boxes, and Courtney has 2 of those 8 boxes. That's where the 3/8 and the 2/8 come into play. Now I haven't really gotten to the heart of my question yet. My question is really asking me, what fraction of the box is left? Well, there are 3 boxes that are left out of 8 total boxes. So that fraction that is left is 3/8. But I want us to take it a step further. Instead of just answering what fraction of the box is left, I want us to also answer how many ounces that fraction actually is. And this is how I can think about that. To find a number of ounces that are left, I can first start by finding the value of one box. Let me change the color so you can see it a little bit better. I can find the value of one box. Because if I find the value of one box, then I know that the unit next to it is the same value, and so is the unit next to it. And this is what I mean. 16 is my whole, but there are 8 total units, 8 equal-sized units that equal 16. So I can divide 16 by 8, and I get 2. So that means that the value of this box here is 2. And because this is a tape diagram where I've created equal units from those equivalent fractions, I know that the value of every single unit in this tape diagram is 2. And I can check my work now, because if I add all of these 2's, these 8 groups of 2, I would still get to 16. Now I have enough information to figure out what is left. This part here. I have 3 groups of 2 in this tape diagram. So the total that is left, I can add the 2 3 times, or I can multiply 2 by 3, and I get 6. So that means that there are 6 ounces left. The fraction is 3/8, but the total number of ounces is 6 ounces that are left. Number 2. Mathilde has 20 pints of green paint. She uses 2/5 of it to paint a landscape and 3/10 of it while painting a clover. She decides that for her next painting she will need 14 pints of green paint. How much more paint will she need to buy? Again, I'm going to start with my whole. I'm going to ask you if you know your whole and if you know what the value of the whole is. If you said yes, I know my whole, and my whole is 20 pints of green paint, you are perfectly correct. Again, let's think about modeling these fractions onto a tape diagram. I want to model 2/5 and 3/10 onto the same tape diagram, which means my units have to be the same. The units are those denominators, the 5 and the 10. So what would my denominator, my common denominator, be for 2/5 and 3/10? Think in your head. I'm going to show the answer up here. My tape diagram is split into 10 equal units. My whole is at 20 pints. So to show the work on the side real quick, the common denominator that we selected here was 10. The 2/5 and the 3/10 would become 4/10 and 3/10. 10 is the common denominator because when you list multiples of 5 and 10, 10 is a multiple of 5 and 10 is a multiple of 10. Now I'm going to label the clover and the landscape onto the tape diagram like I did in problem 1. Now the clover has 3 units out of the 10, which means it's going to be 3 boxes out of the 10, and the landscape has 4 units out of the 10, which means it's going to be 4 boxes out of the 10, just like that. Now all we've done so far is model the problem onto a tape diagram, but we haven't really addressed what the question actually is. Let's read the rest of the problem. She decides that for her next painting, she will need 14 pints of green paint. How much more paint will she need to buy? Well, before figuring out how much paint she needs to buy, I first need to know how much she has left, because that will really dictate how much I need to get. So these boxes that are not labeled yet are the boxes that tell us how much paint is left. So like the last problem, I'm going to figure out the value of how much is left in ounces. Because when I do that, if I know how much is left, then I can see if she has enough 14 pints or if she needs to get more. Like the last problem, I'm going to go figure out what one box is. Because if I know the value of one unit or one box, then I know that the unit next to it is the same value, and so is the unit next to it. Now I have 10 equal units, 10 boxes in the tape diagram, that equal 20 pints. Now to find the value of one unit, because these are equal groups, I have to divide. I would do 20 pints divided by 10 units, and I get 2 pints. That means that this box here is worth 2 pints. And so is this one, and so is this one, and so is the rest of them. And if I added 2 all the way down, I would get to 20. I have enough information now to figure out how much is left. Those 3 groups of the 2. I have 6 pints that are left. Now the problem says that Mathilde will need 14 pints of green paint. Does she have enough? She doesn't. How much more does she need to buy if she needs 14 pints? How can she go from the 16 to the 14? What operation could I use? If you said subtraction, you're correct. You're finding the difference between those two values. When you subtract 14 by 6, you get 8. So her final answer is that she needs 8 more pints so that she's able to paint her next painting. Mrs. Diaz makes 5 dozen cookies for her class. 1/9 of her 27 students are absent the day she brings the cookies. If she shares the cookies equally among the students who are present, how many cookies will each student get? I'm going to start with the students in her class, okay? The problem tells me 1/9 of her 27 students are absent. Let's model that in a tape diagram. I'm going to draw a tape diagram that is split into 9. That way I can show that one of those 9 were absent scholars and the remaining 8 of the 9 were present scholars. So her whole is 27 students. Again, 1 out of 9 is absent, and the remaining units, the remaining 8 units, are present. Let's move on to the problem. It tells me that she shares cookies equally among the students who are present. And then it asks me how many cookies each student will get. So before moving on to work with the cookies or to do anything else, I really need to figure out how many students are actually present. Right now I only have a fraction, right? I only have 8 out of 9 that are present, but it doesn't tell me how many students that is. Like the previous problems, I can find the value of 1 unit and then do repeated addition or preferably multiplication to figure out the total units that I'm looking for. And this is what I mean. Let me erase these highlightings. I have 9 total units in this tape diagram, and those 9 total units are 27. So to find the value of 1 unit, what I would do would be the 27 divided by the 9. And 27/9, when you think of your facts of 9, would be 3. So that means that the value of 1 unit is 3. And if that is 3, then this is 3. Let me make the color the same with those ones. This would be 3 right here. This would be 3. This would be 3, 3, 3, all the way. And if you add those 3's together, if you multiply those 9 groups of 3, you would get 27. So we know we're correct. Now I have enough information to figure out how many scholars are present. How many groups of 3 are there on the tape diagram right now for the present scholars? If you said 8, you're correct. Now what is 8 groups of 3? 8 groups of 3 is 24. Now there are 24 students who are present in the class. Now I have enough information to work with the cookies. The problem tells me that Mrs. Diaz makes 5 dozen cookies for her class. I need to figure out what 5 dozen cookies are. 1 dozen equals how many cookies? 12. So 5 dozen would equal how many cookies? 60 cookies, because 5 times 12 is 60. Now, Mrs. Diaz has 60 total cookies to split equally among the students who are present. So 60 cookies equally shared to the 24 students would be 60 divided by 24. I want you to pause this video and solve what 60 divided by 24 is. I'd like your answer as an improper fraction first, and then as a mixed number. 60 divided by 24 is 60 24ths. Remember, the first number is your numerator and the second number is your denominator. And 60 24ths, when you do 60 divided by 24th, is 2 and 24 twelfths. You could take it a step further and actually simplify the 12s. I'm sorry, 2 and 12 24ths. I read that mixed number wrong. The answer is 2 and 12 24ths. You can simplify 2 and 12 24ths by dividing by 12 12ths. Let me write this properly so you can see it. You can divide by 12 twelfths and you would get 2 and 1 12th. Both of those answers are perfectly correct. So our final answer would be that each student would get 2 and 12 24ths or 2 and 1 12th cookies. And remember, this is only for the students who are present, not who are absent. What I'd like you to do now is take what we just learned, or the skills that we just used, to solve the problems that are on page 28, your independent practice. The strategies you're going to use to solve these problems are the same strategies we just did on problems 1 through 3 in this video. You're going to draw a tape diagram. For most of them, you'll have to figure out the value of one unit and then work your way to find the rest of the information in the problem. If you have any questions, please feel free to call me or text me or email me, and I'd be more than happy to help you. Bye, scholars. Have a great day. What I'd like you to do now is take what we just learned, or the skills that we just used, to solve the problems that are on page 28, your independent practice. The strategies you're going to use to solve these problems are the same strategies we just did on problems 1 through 3 in this video. You're going to draw a tape diagram. For most of them, you'll have to figure out the value of one unit and then work your way to find the rest of the information in the problem. If you have any questions, please feel free to call me or text me or email me, and I'd be more than happy to help you. Bye, scholars. Have a great day.